Hello there, children. Today we are going to work on the review for the section 2.1 to 2.4 quiz. So, first order of business. If I ask you to put something in the form of y equals mx plus b, which is, in fact, your slope-intercept form of an equation, and they give you the slope and they give you the y-intercept, then this should be something awesome for you. Meaning, I can just simply substitute the slope in for m and the y-intercept value in for b. Remember to write your x, and that's the end of the problem. Now, if I asked you to put it into standard form, you'd have to subtract the mx value over, and then make sure you don't end up with any fractions there, so canceling those out. Let's move on to the next problem. Next problem asks you to turn something from standard form into slope-intercept form. Nice thing about this is all I have to do is get y by itself. I subtract 8x from both sides, and I end up with y equals negative 8x plus 1. Now, if for some reason here there was a coefficient in front of y, I would then have to divide by that coefficient in order to have it in y equals mx plus b form. In this case, I don't have to do that simply due to the fact that there is no coefficient in front of y. Moving on to the next problem, which is I want the equation of a line through two given points. Well, those two given points here are kind of nice. They are nice in the fact that I don't have a slope, so I can go find the slope. Now, that slope is found by, if you forget the slope equation, it is m equals y2 minus y1 over x2 minus x1. It does not matter which one you label x1 and y1 and x2 and y2, just that you keep them consistent. So I could have here, in fact, labeled this as x2 and y2, and this as x1 and y1. It would have been perfectly fine doing the problem. So I find the slope. At the point I find the slope, I then, after finding the slope, which is here is 1, remember minus a negative becomes plus, I then go through either y equals mx plus b, substitute my slope in, and one of the points I use negative 5 for x and negative 4 for y. You could have used 0 for x and 1 for y as well. Or I do point slope form, which is y minus y1 equals the m times the quantity x minus x1, and solve the same way. Both are mathematically acceptable. Again, same thing for your next problem here. Your next problem here involves the same process because, unfortunately, I am given a slope. No, I'm not. Well, that's a bother. I have to go find slope. I find my slope, and I put the slope into y equals mx plus b here. Again, you could have used point slope form if you wanted to. And any of the points. I picked negative 3 for x and 0 for y. You could have picked 0 for x and negative 5 for y. Now, when you get this particular equation, you're like, how do I know if I did this right? Luckily, you have 2 points. Those 2 points being x is 3, y is 0, and x is 0, y is negative 5. You have those 2 points for which to substitute things in. You can do that and put those values back in the problem. Meaning, if I put negative 3 in for x in this problem, I should get back 0 for y. If I put 0 in for x into this equation here, I should get back a negative 5. If you do that, then you know the line passes through those 2 points. Moving on. Now, in this particular problem, again, finding the slope, I use this coordinate as x2, y2. Again, it doesn't matter which one I picked to that as long as I keep it consistent. I then use my slope of 8. Use one of my points. I used 1 and 5. I could have also used 0, 3 to solve for b. Combining them back together. Again, once you do this, put either of these points in for x and in for y, and they should give you true statements. Moving through here now. The next problem, quite difficult. Simply due to the fact that it's difficult because I give you a point and then a line, and then I want a certain situation based off that line. I want through the point 4, 0, and parallel to that equation there. Well, when I do that there, My old slope is -1. That's the slope that comes from the line in question. The line in question, in case you are wondering what the line in question, my apologies, the line in question is the line that they gave me in the problem, namely this line right here. So my old slope is -1. That's the coefficient of x. My new slope is going to be -1 also, because parallel lines have the same slope. Now, if only they gave me a point, I could use my slope on that point to find a line. If only they did! Thank you, imaginary voice in my head. Yeah, that's correct. They gave me the point through this coordinate here. I do not, under any circumstances, use my old y-intercept there. That is gone. That is thrown out. I only use this line for its slope. I then use my slope of -1, my point x being 4, y being 0, and solve for my new b value here. The next problem is even trickier, because through this point perpendicular to the line in question, and again the line in question is the line they literally give me in the problem. So that line in question there has an old slope of 3/5. Now if they were parallel, the new one would be 3/5, but it's not parallel. In fact, it is perpendicular, and perpendicular means negative reciprocal or opposite reciprocal. So what I do there is I take the fraction that I have in question, I flip the fractions, so 3/5 becomes 5/3, and then I make it negative. I then use that slope of -5/3, and 3 is 0, to figure out the rest of this problem, which means I use y equals mx plus b or point slope form to substitute it in here. Moving on. Next problem, interesting enough because the slope is undefined. Undefined means a vertical line. If you had a slope of 0, that would mean you'd have a horizontal line. Since it is a vertical line, vertical lines have the equation of x equals. Well, x equals here has a fine equation. What is my x coordinate in this problem? It is -3. Thus, my line must be -3. Moving on. Graphing problem. Alright, it's in slope-intercept form. This should be fairly enjoyable to graph. So what I do here is I plot my y-intercept first. That's -2. I go down 2 on the y-axis. After I do this, I then go to my next point. How do I get to my next point after I have my y-intercept? I use my slippery slope there of 6/5. That is rise 6, 1, 2, 3, 4, 5, 6. Run 5, 1, 2, 3, 4, 5. Boom. This is rise over run. And it's positive, so rising is a positive direction. Going to the right is a positive direction. I also could go down 6 on the y-axis, which is negative, and to the left 6, which is negative. Two negative directions will also give me that positive slope. I don't do that here because if I went down 6 and over 5, that would be off my graph over here, which is kind of pointless to do. My next coordinate here, the tricky part about this is people always forget it's x minus 4. What's the slope there? Out in front of x, it is 1. So I plot my y-intercept of -4 there, and then I use my slope of 1, which is up 1, over 1, up to the right, up to the right. Or down to the left, down to the left. That would also work because of two negative directions. Now, going beyond that, if I give you a problem like this, oh no, it's in, oh man, this is in standard form. I don't want to graph standard form. Well, then you don't have to. If you don't like standard form, and it's a fine form to graph in, what you do is you go, no, not gonna happen. I'm gonna graph it in y equals mx plus b. How I do that is I subtract 5x to the other side of the problem and divide by -3, because sharing is caring. Thank you very much. Sharing is caring, so I'm going to divide every single term by -3. That is going to switch the signs of everything. It's a very key important point here. We switch the signs of everything. Now, if I didn't want to do that, what I would do is I would simply find the x and y intercept of this function. If I'm looking for the x-intercept, for instance, of the problem, the x-intercept, I would cover up my y value. and solve that equation, 5x equals negative 3, and plot that. Now, if I were looking for the y-intercept of this problem, I would cover up the x and solve the problem negative 3, y equals negative 3, which is giving me the y-intercept of 1, which I already found earlier. So both are acceptable. The next problem I have is I give you the x and y-intercept. The y-intercept is negative 4 or positive 4? Oh, positive, so it's up here. The y-intercept is negative 1, so it's here. Oh, over here because it's negative. Now, I then connect these two dots. You do not make horizontal lines here and up and down. That is not correct. I connect my x-intercept and y-intercept. That seems pretty straightforward. Now, you see over here I have equations written. What I could ask you to do is, based upon this graph, write me an equation. Well, how do I do that if I want my equation in good old-fashioned y equals mx plus b form? I need a slope and a y-intercept. Luckily, they literally tell me what the y-intercept is. It's 4. How do I get to my slope? Well, if only I had another point to go from, that I could simply plot this thing. Oh, wait! They gave me the x-intercept. So how do I get from my x-intercept to my y-intercept? I go up 4 to the right 1. Up being positive, right being positive, rising 4, running 1, my slope would be 4 then. In standard form, I would simply subtract the 4x to get both my variables on the same side of the problem. This is all the review you will need to pass and do well on this quiz. Go henceforth and do.